All right, we should probably get started. Wonderful. I'm very pleased to welcome you here today to the Academic Symposium on Climate and Global Change. My name is Robert Johnston, Director of the George Perkins Marsh Institute here at Clark. I'd like to take a few moments to introduce the symposium and introduce our speakers as well, and then we'll launch right into it. So why are we here today? Climate and global environmental change is arguably the most fundamental challenge of our time. Growing climate and environmental hazards threaten the well-being of every human on the planet, along with the natural systems upon which we all depend. For decades, Clark University has confronted the global climate crisis through research and engagement around the world. The tools, techniques, and information developed by Clark University researchers are shaping responses to climate and global change worldwide, with a guiding focus on engaged science to support human decisions and livelihoods. This panel introduces some of the work being done by Clark University on climate impacts, vulnerability, adaptation, and mitigation. Today, we've brought together 4 internationally recognized experts with a common focus on research to inform action, to give you a little taste of some of the work we're doing here at Clark. Before we begin, I'd like to briefly introduce the panel. First, Professor Ed Carr is Director of the International Development, Community, and Environment Department. Ed's research is marked by deep engagement with the institutions and practices of global development and climate change adaptation. He founded and directs the Humanitarian Response and Development Lab, HURDLE, here at Clark. He's also served as a lead author of several global environmental assessments, most recently the 6th assessment report of the Intergovernmental Panel on Climate Change, or IPCC. Rinku Roy Chowdhury is professor in the Graduate School of Geography. Her research is interdisciplinary and focuses on human-environment interactions in land systems in diverse geographical locations across the globe. She's very active in the U.S. Long-Term Ecological Research, or LTER, network, and she's co-chaired the Global Land Program of Future Earth and was a coordinating lead author in the Intergovernmental Science Policy Platform on Biodiversity and Ecosystem Services, also known as IPBES, and their global assessment launched at UNESCO Paris in 2019. Chris Williams is professor of Earth System Science, also in the Graduate School of Geography, and director of the Environmental Sciences program here at Clark. His expertise is in terrestrial ecosystems, global environmental change, and climate change, focusing on foundational research science on the climate impact of forests. His team of researchers is developing action-ready data and tools to provide to decision makers around the world, including such organizations as the Nature Conservancy, the Open Space Institute, the Trust for Public Lands, and multiple U.S. states participating in the U.S. Climate Alliance. And finally, I'm Robert Johnston, Director of the George Perkins Marsh Institute and Professor of Economics at Clark. I'm an environmental economist studying the benefits and costs of environmental change and how humans make decisions with regard to the environment. Among various other roles, I'm currently on the steering committee of the Narragansett Bay Estuary Program, past chair of the Ecosystem Science and Management Working Group of the NOAA Science Advisory Board, and past member of the U.S. EPA Science Advisory Board. I'm also currently editor of the journal Resource and Energy Economics. So that completes our introduction. We'll now begin with 4 brief presentations by each of our panelists, and then with the time remaining, we'll open up the floor to discussions about how Clark can best move forward in the area of climate and global change. So with that, I'd like to introduce our first speaker, Ed Carr.
Thanks, Rob. So, why worry about climate change adaptation and making it more effective? One of the things that we know is since the industrial era started, we've seen 1.1 degrees Celsius of global warming. The result of that has been impacts on people and nature that have been significant, observed impacts. This is not stuff we project, it's stuff that's already happened, that's challenging people's well-being around the world. As we move toward 1.5 degrees of warming, a temperature we're very likely to hit sometime around 2040, we expect that we will see severe impacts increasing, and as we pass 1.5 degrees, those will become even more intense and potentially irreversible. For example, crossing above 1.5 degrees and then pulling ourselves back down later in the century, while a positive move still could result in the things like extinctions, which are not reversible even if you bring temperatures back down in the long run. What this all means is that we are going to have to change the way we live in the world to deal with these impacts. But changing how we live in the world, adapting to these kinds of impacts is not straightforward. It's not simple. There are an awful lot of ways to get this wrong. For example, we could take actions that preserve problematic social structures, things that, say, disempower women and women's opportunities, and as a result, we could compromise long-term development opportunities in different parts of the world. We could implement interventions that make it very hard to mitigate climate change, to reduce the amount of greenhouse gas that we're emitting, thus working against ourselves in these sorts of efforts. Or we could bring to bear adaptation efforts that convince people that all we need to do is keep taking small incremental steps and somehow we'll deal with this, obscuring the fact that really we're looking down the barrel of transformational changes to deal with this. So there's a lot of ways to get this wrong, and what I spend a lot of my time doing is thinking about how to get it right. And I want to talk about that in three big arenas, three roles that I see in my job when I'm addressing this kind of issue. One of them relates to basic research, one of them relates to how we shape policy, and the last one about how we improve program and policy intervention. So, on the research front, my research story probably sounds a lot like most faculty's research story, in that I started on this road because I had interesting research questions about how people were dealing with economic and environmental change that was shaping their lives. I principally started this work in West Africa, in Ghana, and after a few years had an opportunity to take up a project in Malawi with other colleagues, and then Mali, and then eventually Senegal, then Zambia after that, and then finally Uganda. And as my career kind of kept going, as it kept adding countries, the team I was working with got larger and larger, and the amount of data we had in front of us got larger and larger. Today, we have a database of over 1,000 ethnographic interviews, literally years of observational data on how people in different parts of sub-Saharan Africa have been dealing with economic and environmental change. And as you can imagine, across that time, myself and my folks in my lab are also producing a lot of findings. For example, findings that point to the importance of social difference in effective adaptation, how gender roles, for example, really matter in terms of how well your projects work, how important local knowledge is, because of course that shapes how people take in adaptation opportunities. So we did that in terms of getting weather and climate information to people. But along with those smaller, more focused findings are meta findings that come when you've been working on something for 25 years and have this kind of a database. Like the fact that across all of the contexts that I've been working, one big thing we've seen is that when you reduce people's vulnerability overall to the impacts of climate change, opportunities emerge, especially among marginal and vulnerable populations, to actually implement transformational changes of their own in their own lives, to catalyze the kinds of transformational adaptation we need to see going forward. Now, this is all well and good. I actually love this work. I want to keep continuing doing it. However, it's one thing to do research. It's another thing to actually make it effective in the world. If all you're doing is research and then publishing it in journals, you're effectively throwing it over a wall and hoping that someone's reading it and implementing it. If you're counting on that, it's not working out. So what you have to do is argue for it in policy arenas. One of the arenas in which I've engaged in this is in global environmental assessments. As Rob mentioned, I was a lead author of the most recent IPCC report, the section on impacts, adaptation, and vulnerability. And I was a lead author of the last chapter in that report, and the job there was to synthesize everything that the rest of the report had talked about in terms of adaptation, make sense out of it in terms of where we might go to effectively adapt in a way that fostered productive mitigation and the achievement of development goals. As one of those lead authors, I was able to bring in 25 years of experience in research, as well as all the research that had influenced me, all the people I'd read and worked with over time, to bring that into that chapter and actually shape its outcome. Now, why does that matter for policy? Because the IPCC reports are the scientific foundation for the climate change negotiations you hear about all the time around the world. 193 countries actually have to agree to what's in the IPCC report because that is the negotiating baseline now for the next 7 years. So that's one way in which you can pull your research into a policy arena and then actually shape an entire policy conversation at a global scale, potentially for the next 7 or 8 years. So that's great. Maybe we've got this into the policy arena. But getting things into the policy arena is not the same thing as doing things on the ground and in the world. And so that last thing is to think about how to get policy into implementation. And that then speaks to my third role here. I sit on the scientific and technical advisory panel to the Global Environment Facility. The Global Environment Facility is the funding mechanism for all of the large multilateral environmental agreements. So the Convention on Biodiversity, the Convention on Climate Change. When they're funding projects in the world, they are moving this money through the Global Environment Facility. My job on the panel is I'm the panel member for climate change adaptation. My job is to vet projects for scientific and technical merit and to bring the latest thinking on adaptation to the overall work of the GEF. One of the things I've run into over the last 2 years reviewing projects are two interesting problems. One, projects that lacked an adaptation rationale. In other words, it wasn't really clear why they were adaptation. They were asking for adaptation money, but they weren't clearly defining an adaptation problem. The second were a lot of really good projects that were defining adaptation really kind of as preserving what is. And I just mentioned a few minutes ago, you could preserve a really unequal social situation. You could preserve people's perceptions about how they live in the world and really cause significant problems. To address this, I've actually built a tool that the GEF will start implementing in June, which is a decision support tool that helps people design better projects. It's just a decision tree. And all it does is walk people through a series of questions, all the consultants and implementers who build these projects, to guide them into the most effective thinking on adaptation and therefore the most effective projects. And that includes a section that gets at something as basic as, has there been an actual change in the climate? And if you think I needed to ask that, like I tell people all the time, it's why we have laws, because somebody did it. Same problem here. But also getting into more nuanced issues, right? In the name of screening for adaptation need or demand, looking at the differences that people have in terms of their experiences of climate change and why some people feel a need for an adaptation project or not. And getting into why people are actually adapting and how they're adapting gets us into local knowledge and into indigenous knowledge and the importance of that kind of work. And then finally, a step that says, how does all of this connect to other kinds of goals you're trying to achieve? Mitigation, development, biodiversity, et cetera. So the broader answer then is, how do you make climate change adaptation more effective? Through this process I described to you, starting with research, working on policy, moving that into implementation, and then doing it again, iterating, learning from all those things to reinform your questions. That to me is the heart of climate action, and that's one of the most exciting things about the work I get to do here at Clark. Thanks.
Thank you very much. Always a pleasure to go after you, Ed. So I'm going to start a timer. So again, it's a pleasure to be with you here today. And I'm going to be a little bit of the odd one out in this panel in that I'm going to talk primarily about a different kind of global environmental change, not climate change, although these things are, of course, completely intertwined. So specifically, I'm going to talk about changes to global land use and land cover, which the recent global assessment of IPBES that Rob mentioned, the Intergovernmental Science Policy Platform on Biodiversity and Ecosystem Services, that's a mouthful, and we have actually commonly come to the pronunciation of IPBES, more phonetic. So IPBES has unequivocally found, through the work of hundreds of scientists over several years in this global assessment, that global declines of biodiversity are driven most significantly by changes to land and sea use, followed closely by changes to the climate, right? So, and again, of course, these things are not independent of one another. So this phenomenon, of course, has extremely significant implications for human societies and natural systems alike. And I want to really point out that Clark University has been at the forefront of global land use and land cover change research, and indeed founded the initial scientific networks internationally that actually took up this mantle, starting with the Red Book, that many of us affectionately call this, the Earth Transformed by Human Action, which was authored by and organized into a poster workshop by several Clark faculty associated with the Marsh Institute and with the Graduate School of Geography, and of course other institutions. So that work led to the foundation of the Land Use Land Cover Change Program, which was an international science program, the first ever joint project of the International Geosphere Biosphere Program, the IGBP, and the International Human Dimensions Program, the IHDP. LUC then transformed over the years into what is now the Global Land Program. This is an institution that I've had the pleasure of co-chairing for a number of years and continue to serve on its scientific steering committee. So recently, a group of us from the scientific steering committee of the GLP authored this high-level perspective piece that actually summarizes decades of research on global land use, land cover change, kind of presenting 10 facts, alternatively 10 myths about land. And I'm not going to go over all of the 10, but I want to highlight a couple of them as points of departure for the rest of my presentation. So first is this assumption that there is land to spare for nature conservation, right? And I say this semi-facetiously, but point out that 3/4 of the globe's ice-free land is already under direct use, and the remainder actually generates indirect benefits for all kinds of human societies and sectors. Those benefits, however, are fundamentally unequally distributed. So, for example, about 65% of the world's kind of natural ecosystems or natural protected areas are really places where indigenous and local people live and work and carve out livelihoods, but they only control no more than 10% of those lands in terms of ownership, right? So the question arises, how do we actually navigate the trade-offs in terms of social benefits and benefits to nature and of nature in thinking about governance in an adaptive framework? And so here I'm going to share some insights from some of my long-ranging research projects. I'm going to focus on two kinds of research projects, two kinds of land systems, one in terms of tropical agroecology, drawing primarily from Mexico and Latin America, and the other on urban ecology, drawing primarily from cities in the United States. So in southern Mexico, particularly in the southern part of the Yucatan Peninsula, I've had research ongoing since the mid-1990s. This is, of course, the heartland of the ancient Maya civilization and no stranger to anthropogenic long-wave land use and actually adaptation to long-wave climate change as well over the past millennia. And in this context, I focus actually on the region of a large biosphere reserve, a United Nations Man and Biosphere signatory, where there is also prevailing concerns because of being a hotspot both of deforestation and of biodiversity. So in that context, there are contrary sorts of motivations and visions for this landscape, ranging from agrarian futures and compulsions and economic needs, all the way to more conservation needs, with an in-between focus on how do we actually affect perhaps compromises and conservation with development in this context. And I want to point out that this tension is actually central to the two prevailing paradigms of nature conservation globally today, which is, do we protect nature by sharing land for both nature and human use, or do we protect nature by sparing it from human use, right? So there's a land sharing versus a land sparing paradigm. So land sparing will actually separate out the zones for conservation versus use. Land sharing will actually co-locate those functions in the same area in a multifunctional way. And those paradigms actually need us to truly understand how land is being used by the local populations and by multiple kind of sectors and stakeholders. So this is an example of spatial modeling in the southern Yucatan that actually highlights that deforestation and reforestation probabilities across the landscape are really driven by a myriad factors ranging from biophysical to anthropogenic. But in particularly, I want to point out that policy factors are a huge driver of deforestation and reforestation. Okay? And in particular, policy factors have unintended consequences. So even green policy instruments operating on the landscape have the effect oftentimes not of stopping deforestation, but displacing it, right? So there's spatial contagion effects that become incredibly complex and important to understand in trying to affect governance solutions. Over here, I'm also pointing out that in these land systems, particular stakeholders such as smallholder farmers are actually extremely heterogeneous. They don't operate with the same decision logics, and it is incredibly important to understand the diverse decision-making rationales involved, and also important to understand that the dominant strategies by people are not necessarily something that translate into the dominant land covers at the landscape scale. So there's a disproportionality here to keep track of. In this landscape, recent data also point to evidence that we are witnessing a regime shift from a formerly land sharing landscape with Sweden, mosaic agriculture, traditional agriculture, to a more land sparing regime with all kinds of implications, both for landscape level diversity and biodiversity, but also for territorial sovereignty and indeed justice. So switching to, let me see how we're doing. Switching to an urban example, I draw from a study that several collaborators and I have engaged in over the past decade plus that really looks at urban residential landscapes and points to similar questions of complexity. So for one thing, we find that relative proportional tree cover in urban neighborhoods are, and I am out of time, so are actually disproportionately sort of driven by multiple anthropogenic and biophysical factors, but they're also rife with nonlinear relationships, and the emergence of different kinds of yardscapes in urban residential landscapes is a testament to the fact that there are operating policy instruments all the way from zoning to the presence or absence of neighborhood associations and homeowners associations that end up shaping the biodiversity in our yards and what sorts of ecosystem services our yards can actually generate. So I'm just going to end with saying that we need to understand the complexity of land systems as coupled social natural systems, and particularly understand the ways in which institutional drivers operate to shape landscapes and the ecosystem benefits associated. Thank you.
So greetings, everyone. Thank you for being here in attendance and for watching online. My name is Professor Dr. Christopher Williams within Geography and Environmental Sciences, and I'm happy to present to you today a little glimpse of what it is that I do in my research program as an example of the exciting work around environment at Clark. I direct a research lab that I call the Biogeosciences Research Group. And broadly, what we study is forests and climate. We have a diverse set of funders and collaborators, which are illustrated here. And we get this diversity partly because of the range of topics on which we work and the way in which we bridge from basic research to research that has real impact in the world and that is engaged with policymakers, with decision makers. We gravitate to use-inspired research that has real application and that answers timely questions in a way that meets decision makers and policymakers where they're doing their work. We try to work on things that are important to society, and we're excited to keep doing that here at Clark University. One of the things we specialize in is big data geocomputation. I am, after all, in a geography department. We bridge that or merge that with computational analytics and analysis and modeling that allows us to bring things to market in a way that's different from what a lot of other institutions and universities and programs do around the world. We bring this arsenal to answer questions broadly about how changes to the face of our planet are influencing the climate system. As you've been hearing from other speakers, one of the things that makes Clark research in this area really special and unique is that we don't stop at the basic research. We have foundational basic research, but we bring this to applied science, applied applications in the real world, and there we don't stop either. We go all the way to outreach and education that reaches service to society. Working across this range, for me and for all of us working in this lab, brings a real vitality and enthusiasm to every day. It makes our work more relevant to society, and it makes a more vibrant and engaging environment for our students so that they see not just the research in isolation, but also the real-world impact that it has in practice. So today, it's my pleasure to have the chance to offer a few examples of the work that we do and how we bridge from basic research to broader impact in the world. So the first example is this. Almost every day we see a new headline about a new commitment to plant trees, to slow deforestation, to expand forest cover as climate actions to help fend off the climate change crisis. But few of these initiatives have good intel on how effective they'll be at cooling the climate system. We're using observations from satellites, measurements from forest plots on the ground, and high-tech analytics to figure out where tree cover would best serve us to cool the planet. This is one example of what we found. We found that forests cool in many places, as was expected, and that there's a lot of geographic variability. And maybe most importantly, that forests, not everywhere do they cool the planet. In some places, the presence of forests actually causes a warming. Here, it's shown in the reverse because we were analyzing forest loss. We were analyzing the climate impact of losing a forest, and you can see across much of the Intermountain West in the United States, planting trees in those places will have actually a warming effect instead of a cooling effect on the climate system. Or losing trees in those areas would have the opposite. They would cause cooling. Unfortunately, there are quite a lot of companies that are out there looking to plant trees in exactly this environment. We're trying to bring truth to that reality. This is because forests are darker than the surfaces around them. Other surfaces tend to be much brighter. It's kind of shown in this image. Partly it's because of snow cover and the highly reflective nature of that snow cover, but it's also because of the bright background soils and how that contributes, a reflection of solar radiation, sending it back out to space. Decision makers are starting to use our data and to use these data in their practice to identify priority areas for expanding forest cover that would cool the climate system, and also to mask out areas where, in a sense, there's a no-go for reforestation activities, where it wouldn't make sense to avoid forest loss or to increase forest cover as a climate action equivalent to avoiding emissions of fossil fuels. This work is currently funded by the Nature Conservancy to take it to a new level. This is part of Jeff Bezos's Earth Fund and their very large award to the Nature Conservancy to take this analysis and scale it up to go global, and also to go much higher resolution than the large blockiness that you see in this picture, to bring it down to the scale of decision makers, policy makers, and get it into their hands so they can actually use it on a day-to-day basis. We're delivering the data products as part of a decision support interface that makes it easy for practitioners around the world to figure out the potential climate solution associated with expanding tree cover or avoiding forest loss, and where that really doesn't make sense. So that's the first example. Here's the second example. It's related. We all know that forests soak up carbon dioxide out of the atmosphere, and that they store it in wood and soils, and we're also learning now how much, how fast, and for how long, and that's what our research is about. Diverse institutions, from state governments to conservation organizations to individual landowners and even banks and corporations, are asking how much carbon their forests are taking up. They also want to know how this can be credited as a climate action. Our lab has used data synthesis, geocomputation, and computer modeling skills to fill that information gap. The map shows one of our results, displaying patterns of areas with high carbon and high carbon uptake and removal by forests, and other areas which are less active at removing carbon dioxide today. We're writing this up for scientific literature, but that's not where we're stopping. As Dr. Carr also suggested, that would be inadequate. We're going much further than that. We wrote a public report and posted it freely online. We made our data sets available freely in formats that are readily accessible to potential users. And in the past couple of years, I personally have conducted over 30 workshops, press briefings, communications, and correspondences with state and federal officials, with non-governmental organizations, conservation organizations around the country, communicating not just our results, but also about the opportunities for putting them into practice. We've delivered custom data sets in all sorts of formats, including in state reports. We've posted our data set online in an interactive web mapping tool
that's hosted by the Nature Conservancy. You can fly through our data there. This is just one high-level example of the patterns that are displayed. And people even from the US Forest Service tell me on a regular basis that they're really learning about forest carbon and our forest resources just by flying through these data that are hosted in this location. It sparks a lot of discovery, a lot of curiosity, and I encourage you, if you take a moment, to take a look at your favorite place, your backyard. Here's one example. You can zoom in to the scale of a city and even draw a polygon to analyze how much carbon is in that landscape, what we expect in terms of carbon uptake in the near future, and how much that could contribute to climate change avoidance. It's research like this in service to society that really gets me out of bed every day. As I said, we're also packaging this for individual states so that they, and we're interacting with their offices of conservation and climate and environment to help them understand not only the inventory reporting that they can do with our data sets, but also the planning for climate action with forests that we hope they'll do and that they are indeed planning, in part using our data sets. So President Fithian has inspired us to think big about a culture of possibility, and by leading with renewed appreciation for the impact that it has in the world and that Clark has in the world. I hope that the examples you're seeing today will inspire all of us to think about how we can do more of that and to celebrate what it is that we're already doing and think of those as special opportunities for expansion and growth. Clark definitely has it. It's a smaller institution with a very seriously outsized impact in areas such as this, global and climate change. We have impact that gets our name out there, impact that provides opportunities for our students to be inspired and to learn collaboratively, working in teams on our projects and as members of those projects, and to do great work of importance that serves society and that helps them launch into the world for lives of fulfillment. And that's something that we're all very proud of. I'd like to close with an example of one area that I think is particularly ripe for potential future growth at Clark. Society is on the verge of a massive transformation of energy production, in transportation, in heating, in cooling, in the way we power society at large. I don't think people realize just how huge this transformation will be, and I'm sure that people don't realize just how close we are to being able to solve this problem with the technologies that we have at our fingertips. That's why I'm excited today to propose the possibility of a new incubator at Clark University around the transition to clean energy and a climate-safe future. Its goal would be to equip society with the tools needed to envision and to design a transition from where we are now to where we need to go in the future with deep decarbonization of society. By building from my team's foundational work in natural climate solutions, we're well poised to roll out a new research portfolio and applications domain, a hub that would perform outreach and education around climate solutions in our built environments. Solutions that reach the scale necessary to truly protect the climate system at the global scale. Society needs bold, new design thinking on this crucial topic, and I think Clark is just the place to help fill this gap along with other institutions. I hope we have that opportunity. Thank you.
Okay, I would like to move us now from forests to the coast and think a little bit about how we react to a changing climate. Ed spoke about climate adaptation in one way, thinking about how people feed themselves. I'd like to talk a little bit about how we protect ourselves from hazards that are caused by a changing climate. So climate change impacts, one of the major impacts, particularly around this area, includes sea level rise and an increased incidence and severity of coastal storms. These obviously have wide-ranging impacts on the things we care about, on our homes, on roads, on the systems that we use, beaches and mangroves and wetlands. And a myriad of adaptation options are available. All involve costs and trade-offs. If you read the headlines, you might think that the primary goal is to protect the things we build, our homes, our roads, right? But unfortunately, when the most common approaches to protect the things we build threaten the other things that we value, wetlands, beaches, natural systems, right? And so thinking about how we solve this crisis requires an understanding of how human and natural systems interact along the coast. all of these solutions must confront uncertainty. Right, so here we have just some simple graphs about projected rates of sea level rise globally and across the continental US. And even just considering these averages, you can see a wide range of uncertainty. Right? And as you get even narrower, looking at specific areas like, say, Massachusetts or Virginia, you see even greater variability, not only year to year, but week to week, and exacerbated by storms and other flashy events. So how do we adapt, right? What I'd like to use is just a simple example of one system that has extremely high value to people, right? Salt marshes, right? So coastal marshes, right? These are highly valued systems, right? Whether we recognize it or not, these provide a wide range of services that we value. They filter water, they support wildlife, they protect us from flooding along the coast by absorbing floodwaters before they can flow inland. Right? These are just a few of the many services they provide. The challenge, however, is that we armor the coast, right? For example, building seawalls and groins to protect the things we build, right? They can squeeze out those salt marshes and other natural systems. As the water comes up, they have nowhere to go because they're confronted with this hard concrete wall, for instance. And so they get squeezed and they drown. It's called coastal squeeze. And so when we think about, well, how can we protect these valuable natural systems while at the same time protecting the other things that we value, right? And so we really have to understand the dynamics of how natural systems work and how human systems work, recognizing that preservation is costly. For example, one of the ways that we would preserve salt marshes is to purchase and preserve or otherwise preserve undeveloped, unarmored land where those marshes can migrate as the waters rise, right? But that's costly. So let's think about what might happen to these systems. This is an example from the Virginia Coast Long-Term Ecological Reserve, LTER, and this shows the blue in that color is salt marsh, right? And this shows what's moving from left to right, what is anticipated to happen, what we predict to happen as sea levels rise, from current levels all the way up to a fairly pessimistic level of sea level rise. Keep in mind that sea levels is rising in Virginia much faster than many other places in the coast. And so you can see that, that at high levels of sea level rise, that marsh is basically gone, right? And what it remains is solely due to the ability of that marsh to migrate inland into forest and farmland. So what do we do, right? Well, one thing that many organizations, such as the Nature Conservancy, are doing is seeking to purchase and preserve land for that marsh to move into as sea levels rise. But that's not free, right? And so how do you plan for that strategically? Well, you have to first figure out, among other things, what that land is going to cost, right? And so we can predict that, right? And so I worked with one of my graduate students who's now working at EPA, George Gardner, to try to predict across the eastern shore of Virginia where this area is, well, what would this land cost as you move forward so you can make effective plans? But you also have to consider some of the complexities, right? Additionality. That basically means what additional you get from your actions. Think about it. Not all land is going to be armored. Right? So you might spend money to preserve a parcel of land that will never be armored or protected, and so effectively you've wasted your money. Right? So we have to think about where people are going to armor the coast. We can predict that as well. Right? And so taking observations of where armoring is, cross-referencing that against what we know about the landscape, we can predict where and when armoring will occur. We can overlay that with the costs, with models from coastal geomorphology that will predict where those marshes will go. And we also have to consider that you don't want to put your eggs all in one basket. We don't know what sea level rise is going to be, and so we have to come up with robust alternatives that mix and match our preservation investments, much the way you mix and match stocks and bonds in a financial portfolio. And so we take all these systems together, in a large natural human systems model to basically determine what exactly should we be preserving and where should it go, creating heat maps like the one you see here. And interestingly, it turns out that when you run those models, that in fact what we're doing now isn't particularly optimal. Right? If you look at what's being preserved on the land right now, it's all low-lying marsh and forest land. And what's going to happen over time is that that's going to disappear, right? And if we develop all that upland, the marsh is going to have nowhere to go. So what our model shows is that, in fact, we should be spending much more effort preserving what is now slightly higher elevation farm upland. That's where the marsh is going to go when it's particularly highly valued in the future, when marsh is very scarce and otherwise won't have anywhere to go. Right? So now, as mentioned by our panelists, the challenge is working with the folks down on the Eastern Shore to figure out how to get from where we are, 14% of that high elevation agricultural land that we should be targeting, to somewhere between 60 and 92%, which is where we want to be. Right? That's not easy, but the first challenge, before we figure out how we're going to get there, is to learn where there is. And with that, that's the end of our presentation or presentations. And what I'd like to do first is to open up the floor. I'd like to first thank our presenters. We've just spent some time speaking about some of the work we're doing here at Clark. And I'd like to open up the floor to you, the audience. Any questions, comments for the panel? Let's see, Doug. You'll have to hold your hand up high because I can't see with lights. Yes,
Up front.
Please. Yep, go ahead. Oh, good, there's a mic.
Yeah, thank you so much for the wonderful presentations. So my question especially goes to Professor Ed Carr about your work around adaptation, especially in the LDCs, given your extensive research in Africa. So I know there's an issue about loss and damage and how it's being reported, especially from the least developing countries, and the role like funding plays, like especially with your role at the GAF. So I know the IPCC has like most scientists, and Africa is so underrepresented in the scientists in the IPCC. So which brings an issue, I think maybe there might be issues of loss and damage in Africa that are so underreported, so which gives a challenge on how to address some of the issues. So like what could you recommend given your work in Africa? That is it the scientists in Africa who lack like some kind of socio-technical capacities that need to be built for them to take part, in the global environmental adaptation processes? Thank you.
Thanks. First of all, it's a really good question. You've got several pieces to it. So let's start with the participation of African scientists in large global assessments. Maybe 30 years ago, the barrier was capacity. It's not the barrier anymore. The barrier now is that most of my colleagues in sub-Saharan Africa, based even in universities, the salaries frankly aren't that good. And so they're taking on consultancies and other kinds of work, whereas the IPCC and other kinds of assessments are volunteer work. They literally cannot afford to be on the IPCC. So that's actually the structural barrier. And there's a real conversation happening inside the IPCC. I don't know what's going on in IPBES yet about actually paying some people for their time to do this work, to balance some of that out and to create more of those opportunities, because that's clearly a structural issue. But the absence of some of those folks, and therefore a question of sort of the diversity of the people conducting the assessments, the inclusion of people in those assessments, yeah, it does shape the content of them. The issue of loss and damage, though, is a different challenge. I don't think there's a single person on the IPCC, the 270 authors, at least of the working group I was in, who would say to you that loss and damage isn't a real thing. And by the way, when we talk about loss and damage, we're talking about the losses and damages experienced by people as a result of climate change. Very often climate change they did not create, if we're talking about like sub-Saharan Africa here. I think everybody knows that's real. The problem is that's a political question, because the words loss and damage have become, in the climate negotiations, somewhat toxic because that implies an obligation, and then there's arguments about how you meet that obligation. So that's actually the bigger challenge. But we do know where the impacts have been. I think we can always refine that, but that's not our barrier. It's a barrier of, again, why aren't we getting some of the scientists in? And that's a structural problem. And then there's a politics problem around loss and damage. But I think that just speaks to some of what you heard from everybody here. That's why we can't just do basic research. That's why you actually have to engage in the political processes. That's why you actually have to work with your colleagues on a range of different things to think of ways to get more people into these whole processes. Last really quick point on this, one of the greatest things the United States ever did in terms of building capacity in other parts of the world, the US government used to directly fund the PhDs of a lot of people from around the world. They used to just pay for it to come here and do that. Most of those programs were ended in the late 90s and early 2000s. And it was a disaster to end them because a lot of the capacity we have in a lot of the countries, a lot of my partners were trained through those programs, and it built tremendous capacity, but we're seeing an erosion of that capacity now. And we really need to find ways to spin that back up in the future so that we can actually see long-term building of capacity inside these countries. So that's just a last point on that. Thank you. That's a great question.
Thank you. So this question was inspired by initially I guess, Dr. Williams and Dr. Carr shared sort of similar frameworks for looping research and policy and implementation. But I was wondering if any of you had more to speak on how frameworks can be communicated with like your average NGO trying to make a difference. Like, how do you take those decision support tools from huge high-level decisions to better communicate them to everyone?
Yeah. Okay, I'll start. First of all, a lot of time. It takes an immense amount of engaged conversation. Second of all, you really have to listen to where they are and what they're interested in, because just talking at people doesn't get the job done. So listening is actually one of the first parts of the job. Figuring out why they're there, what they're curious about, what their needs are, and then ultimately doing the work that helps answer that. And oftentimes we've found that we actually had already done that work, but we just didn't communicate it in the right ways, or we didn't package it, and a subtle change can make all the difference. A third piece is building confidence in the work that we've done, and part of that is helping to deal with what I'd call channel confusion. There are other groups who have done things similar to us. Sometimes there are subtle differences that we academics spend a lot of time worrying about, and as we should. But oftentimes they point in such a similar direction that it ends up just being a miscommunication or a confusion rather than a real barrier. But we need to demonstrate that our data product shows something similar to someone else's data product and talk honestly and openly about the advantages and disadvantages of our technique versus another, or where maybe they're very similar and you could use either, and have some humility about that. So those are just a few of the key elements that I would put forth, and I'd be happy to listen to what others offer.
I would just like to make one additional comment, that we also, the length and depth of engagement is important, right? I often worry a little bit about what I call parachute science, where you do your work in a lab and then you launch yourself into a policy climate and say, oh, I'm here today, I'm here to share my wisdom and my intelligence. And the people who have been there for their entire lives and have worked there, well, who are you and why are you coming in and talking at me, as Chris mentioned? One of the things that we have to constantly teach ourselves is that to build that trust, to build that authority, you need to sit with people making decisions. You need to engage with them for a long period. For example, I didn't speak about it today, but a lot of my work is with US EPA, and I've been working hand in hand with folks from in the state and federal levels of EPA for decades, right? And so there's a certain degree of trust that's engendered by that allows us to work together to solve problems, right? So we have to get out of our classrooms, get out of our offices, and live in the real world with people making decisions. And that's what's going to enable our work to make a difference.
100%.
If I could follow up briefly as well. So in a lot of my research, I've engaged at kind of global policy platforms and programs, but I want to contrast that with a very local example. So along with a group of Clarkies, students of mine, we are actually partnering with Mass Audubon on a very specific climate resiliency project that they are embarking on as we speak. It's going to be a long-term effort. It is basically a watershed restoration effort, a hydrological restoration effort in Broadmeadow Brook. Many of you may have been to the Mass Audubon Broadmeadow Brook Sanctuary. So they're really interested in kind of the environmental justice aspect of this as well. So Broadmeadow Brook is also an environmental justice community, which the state of Massachusetts defines on language isolation, race, ethnicity, income criteria. And one of the things that Clark is assisting them with is to conceptualize what equity can look like in an ecological restoration program, right? And kind of think about reversing outreach to in-reach. How do we actually think about who the community is, right? And their experiences and engagement and values in terms of the neighborhood and the local environment and their exposure to varying degrees of flood risk, and think about using that information to shape the restoration program, right? So to really flip the outreach. But it too is a long-term commitment, as both of you have laid out. This is a commitment for the long haul. So we're, I'm excited to partner in this for hopefully 10 years. We'll see.
Longer.
I love working at Clark. They said it all. I mean, no, seriously, it's fantastic. They said it better than I would have said it. That's perfect.
Awesome. Other thoughts, questions?
Thank you all for your presentations. This has been a fascinating panel, and I'm particularly, I don't have that much recent experience or exposure with Clark's scholarship that's happening and research. So I'm really impressed by the amount of data that you all seem to have. Yeah. I want to say in your back pockets. So in my mind, this raises issues about data governance and who, where the data comes from and who actually gets to make decisions about what happens with the data. And so I'd be interested in your comments along those lines.
Yeah, I can jump in, but do you want to start?
Yeah, I can just speak briefly. That's such an important point. I mean, one of the things that's wonderful about a lot of the data that we're using, speaking for myself, but also kind of projecting others, is that these are data in many cases that we've created, right? Linking with data that are already out there, right? So in many ways, we have a lot of authority and flexibility to share that data, to make it available. And increasingly, one of the things that we're seeing, and certainly in my projects, and I would assume with others, is that these data are increasingly being shared on public platforms, right? The data that I just showed you, including data from my other projects, those are all being posted in publicly available locations, right? So whenever we publish results, those data go out there along with the model results so that people can replicate them, so that anyone can go out and find those data and do what they want with them, right? So we're not worried about kind of protecting our data. Once we get results, we want them out there. We want them to be shared. We want people to tear them apart, not only to use them, but to be able to question our results, to say, well, do we stand behind what we do? And I think we do. And so we want people to be able to push on our data, push on our models, and make sure that they hold water.
Should I jump in?
Go for it.
Yeah. So it's a great question, and it comes up a lot for us because we do work with big data, and we procure data sets, we produce data sets, and we serve those to the public in several different ways and formats, and it's not always effective. We try to make them, our goal is what Rob just said. We want them to be publicly available. We want people to be able to use them. We want to discover the warts and see them in practice. That's why we made them, after all. And so that's our aim. And one of the places we post data sets, for example, is a data archive and distribution center maintained by the Oak Ridge National Laboratory, a DOE site. We also work with NASA a lot and post our data sets there. And those are great archives and inventories, but we've also found that oftentimes it's not just about posting a data set, because they're massive. Very few people know how to work with the scale of data we produce, and yet many people really would value information content. They'd value the data subsampling opportunity. And so we've started to do things differently from the way we used to do it. The community of scientists has gotten much better in this regard, that we now actually, even when we submit a journal article, it's a mandatory requirement that our data be publicly posted. But that can mean a lot of different things. Sometimes we post through the Nature Conservancy, and they've been a great partner. It's not always the same longevity and long-term curation that we would get out of one of these other servers. Sometimes we now post through interactive web interfaces. And for me, honestly, it's great for people outside, but it's wonderful for me as well, just to explore my own data sets. I learned so much by investigating them on these web tools, because I can fly through them and discover things on my own. And so it's been a really significant part of our work to conceptualize how we should do that better. And we hope that it's having the right effect. Lastly, I'll just say that README data files are very important, but that's not enough. Kind of to Ed's point, Ed Carr's point, we need also to have kind of user support guides with case use studies that illustrate where our data, what the applications for which our data sets are appropriate, and applications for which it might seem appropriate but really wouldn't be. And we're not only producing that in printed form in documents that are posted alongside the data sets, but also trying to do a lot of communication outreach, once again, as people come to us and ask about those potential applications. It's actually a big part of the work.
Any other thoughts on that?
I do. I'll go in a slightly different direction, but really quickly. So I work with ethnographic data. I work with social data from people, and there's two kind of major challenges there. But I'll go with the easier one, The US government hasn't the faintest idea how to archive ethnographic data. No, literally, they don't know what to do with it. And as a result, they've just started exempting projects that use it from actually having to archive the data, because no one knows how to put it up or what to do with it. And that creates a huge problem, because of course, then it's not publicly available unless somebody asks. Even if you have really well anonymized all that kind of data, it can be a real challenge there. The other side of it, and this goes to another thinking on data governance, is who produces, who gets to use it, that kind of thing. My lab's been able to get a lot of money to train people up in capacity to do data collection. We have utterly failed, despite repeated efforts, to get the money we need to build people's capacity to do the data analysis in other places. We, and I do mean my lab, me, leaning really hard on USAID, the Agency for International Development, and its new climate change strategy to try to make this one of their priority areas. And we're part of a bid, Clark, actually many of us here at Clark are part of a bid on a huge $50 million adaptation mechanism coming out of USAID, where we have pushed very hard for that being one part of what they need to start doing. If they're not going to pay for people's PhDs here, can we pay for capacity building in these places so that folks can, in fact, govern the use of that data where it came from, instead of it always being governed here?
So we've got about 2 minutes, and what I'd like to do with that little bit of time is to ask those on the panel, any other comments? Anything else that you would like to mention in the last few minutes before we leave?
I have one, and it pertains to the previous point about data. And I think one of the really important conversations that we're having, that we should be having, is about the difference between data and information and knowledge, right? So, and I think, to me, your question actually was about also sort of, kind of knowledge and whose data,
Yeah.
right? So, kind of, yes, social and ecological, but even on the social side, whose knowledge is being represented, and do they have a say in co-producing your research questions, right, in the first place? And that is very much a direction that these global platforms of scientific research are embracing really actively, and certainly the Global Land Program. In previous eras, we were more of a scientific research institution, and we still are that, but we are partnering with the International Land Coalition, with Via Campesina, and other sort of social movements that are fundamentally about land sovereignty and kind of curious and concerned about representations of their knowledge in these, big data systems and so on. But it's a complicated terrain. I'll just leave it at that.
Right.
So the only thing I was going to say really quickly is one thing, and I'll say it very, very fast because that's counting down really fast. what struck me listening to this is how you see how much the Venn diagram is here, like how much overlap there is, but how people keep coming at it from all these different angles. That to me is not a problem. That's exciting. That's what we need to do. We have to come at these challenges from as many different angles as we possibly can, because none of us have truth. We have a lot of facility with the stuff we know how to do. We're not going to solve any of these problems by ourselves. We're not working in stovepipes because that's not effective. It's thinking about how we work together. In a place like Clark, you can do that. We're small. I know all my colleagues. I know a bunch of people in this room. That's not always true at these giant research universities. We have an opportunity to do something a lot of people don't get to do.
And with that, I mean, I think that's a wonderful place to end. We are out of time, just with the idea that this is all integrated, right? We're working across disciplines. We're working with the users. With that, I'd like to thank our panel. I'd like to thank you, the audience, for attending. We look forward to working with you as together we try to confront this challenge of climate change. Thank you. Thanks.